Hi there. While working on another video in my unfinished new workspace, I decided it's time to install this LED light that is wall mounted, has a switch, and it's adjustable, fully adjustable, at least in theory. So it should help with more directional light when I have something on my workbench and these lights are not enough. I will have something a little bit more and closer. So let's get to it. The light itself, it's Lucy AB, whatever, 5 watt, 420 lumens. 420. Looks good. Little switch somewhere around there. It's from Top Light. Light for life. If they say so. 3000 kelvins. In theory, similar to these two, which should be dead. Let's install it and see. But first, open up the box. And yes, there is a black variant and a white variant, and I went for the white one just because I would prefer as much as I can from this area to be light reflective, not eating up light. Oh, nice switch. I like it. Anything else? Presumably some mounting hardware and instructions. Yep, exactly as expected. Let's open stuff up. Okay, we have here the safety instructions. Feel free to pause at any time. The light itself looks pretty cool. Should diffuse the LED light quite well from what I see. Highly adjustable. Again, nice switch right there. But I might be using the switches built into that. Who knows? But weirdly enough, doesn't come with a cable. So I didn't realize that. Luckily, I have plenty of cables to use. Presumably through here we will enter with the cable or something like that. Who knows what the main idea was? Maybe to have a cable coming from the wall directly or something like that. We will find a way as always. So let's open this up with the included little Allen key. Okay, so this little thing is inside of this plastic protection, and that's about it. So we have 220 volts going in there through this metal tube, which I hope from the bottom of my heart is well insulated inside of there and not just some wires directly inside of a metal. Because who doesn't want to touch a piece of metal with 220 volts going through it? I don't recommend you buy this light, honestly. It is, as they say here, double insulated, so it doesn't even require a ground, which is awesome. You know that I am going to add a ground into that screw right there. Ah, Jesus, what they build in these days is incredible. Without me adding a ground in there, I'm not going to use this ever. So let me search well for a wire that has ground on it. Jesus, what they can build, it's incredible for me. A good while and many modifications later, as you can see, I cancelled the button. Put some hot glue in there so it will not move. Cut all the wires, removed that switch because I'm not using it. I will have a switch right there that will be cutting the live wire going to this. I added this grounding in here, and now I just need to put back this plastic, which I also kind of prepared right here to close on the wire itself. And then I will also put a bit of hot glue all around to make sure nothing moves in here. But yeah, apart from the plastic housing and the metal and this, I'm not really using the rest. Attaching the support on the wall with this type of fasteners for cement plus brick. So if you have cement plus brick, use these thingies. And then obviously screws. Support is on the wall. Took out the little screws with a tiny imbus or Allen, not sure how you know it. And now simply all of this, which is held in place, the wires in the correct position with hot glue. Now I simply slide it on top. Sorry, didn't show properly. Slide it on top of this and put the screws in both holes on the sides. And we are done. And voila, stupid design. It's pivoting and it's rotating on the, how you call them, on the screws. So I need to take it out and put a spacer on the bottom side where we have the flat plastic, so it stays at least like this. Great, even more work. And I present you 3 layers of double-sided tape, which will act as spacers plus double-sided glue tape basically, so this will not move anymore. And it's on the wall, not moving anymore. So as you can see, lift it from the bottom with the spacer double-sided tape, bottom not working anymore because I basically have this thingy and great flashing light. So I will not be able to use this thing while filming. Really? So they are not even using the how is it called, a diode bridge or something like that. Great, perfect. So I found my rectifier. It's a bridge rectifier, maximum 800 volts at 10 amps. I think it can take the 5 watts that this pulls. I need to get it out of there, unglue this from the wall and put this in there. So I rectify the voltage before it powers this thing up, because they didn't do it. Stuff these days is made as cheaply and as badly as possible just to get our money, and I'm starting to hate it. Luckily I keep all boards, removed the capacitor in here, removed the screw, and now I need to unsolder the diode bridge. And it's actually a 4 amp diode bridge. I searched for another data sheet. I didn't have the good one at first. It's a 600 volt 4 amp, and it actually can take 2.3 amp without a heatsink. And I think we are using 0.0 something amps with this, so we are nowhere near overheating this or probably heating it at all. So this is what we are using, 0.02 amps, maybe even 0.03, but it's nothing basically to what this diode can actually take. I present you my little diode right there. Its feet are in there. I cut a feet, one of the feet shorter. Feet. So it had enough room to come here, and I bent them, and here is positive and there is negative. So AC in the middle, plus, minus. I might have gotten the polarity wrong, so then it will not light up. If it's right, it will light up, and I will start insulating this. But for the moment, it will be just a test. Be back in a second after I plug it in. And it's on, but still flickering. What? Well, I'm going to try and solder the wires the other way around, but it shouldn't be working in theory. As you can see, still flickering, so I'm going to try and use a smoothing capacitor, and it needs to be mains rated. Awesome. Another old board, that the first one with the diode was from a dot matrix printer, a NEC, And this one, the board is from a TV, and in the high voltage area, mains voltage, not really high voltage because this is even higher voltage. In here we have a 400 volt capacitor, 100 microfarads, should be good enough. I will test it to make sure it still has that capacity, and I think it's kind of the biggest one that I can fit in there, so we'll see. Let's do this test. Let's change the light level in the room and see various scenarios. Nope, zero flickering. And let's shut it off. And the little capacitor, oh no, I shut off the wrong thing. Shut it off. And only now it's fully closed, but that could still presumably be a little bit charged. So no touchy, no way near it. I'm going to see what value I need to put, I think, in parallel with it, a resistor, because in theory that discharges it, but you saw that it takes a little while. So if this is at any moment running and I directly unplug it and make a short between the pins in that, I get zapped. So this needs a resistor in parallel with it. Okay, so checking with my PicTech. About 10 minutes later, without a bleeder resistor, this is not going to go easy, is it? Let's see how I can do it. Still high voltage, 67 volts. You can see the high voltage on the PicTech in the left corner. So clearly this needs a bleeder resistor. But the problem is that it should be a fairly big one if I want to bleed this thing in a few seconds. Otherwise, it will take a minute to bleed it out, so I can still electrocute myself in there. Or somebody else that doesn't know to be careful with this thing because I put a capacitor in it. Because it seems this has a rectifier but doesn't have a smoothing capacitor. So I cannot open that because the clips are somewhere deep inside, so I would break them if I try to open that and damage it. So I'm actually adding another diode bridge and a capacitor, but I found this, which is 10 times lower value. It's a 10 microfarads instead of 100 microfarads, and it's at 250 volts instead of 400. It was better 400, but 250 volts is still mains rated. And it's still in the high voltage area, mains area on this PCB. I'm not sure if it's marked on the back of it. Kind of. You can see some traces. So in theory, I'm still good with this on mains, and it should bleed out about 10 times faster, and I can basically use a 10 times lower wattage resistor. Hopefully I will not melt anything in there. So let's pull this out. Hopefully it's enough for that thing to not flicker. We'll see. Checked this with the PicTech and it gave me 12 microfarads. The other one only had 85 from the 100 it should have had. So this one seems to be quite well in spec, maybe even a bit over spec, although maybe a bit of measurement error. But anyway, let's test and see. Let's see. Oh, smooth enough. Test various light levels, see if then it's flickering. And let's see how fast it goes out. Kind of not that fast, although let me turn on the main light. My camera was compensating a lot, so it's going off way faster than the previous capacitor, but still enough to do its thingy. So this is the winner. Let's see how quickly we can drain this with a smaller resistor then. Okay, found where is it? Camera focus. 2 watt resistor. This should bleed it down from 230 volts in about 2 seconds, but it will take less than that because this helps bleed it down to about 80 volts, and then the LEDs probably don't conduct any more electricity, so they stop consuming and working. and then this will actually kick in. This at 230 volts needs to dissipate about 0.5 watts of heat. It can take 2 watts of heat, so it will not blow itself or burn itself, but it will be in a confined space. So I want to test with another PicTech tool, so thanks PicTech for this. I want to test how hot it gets. If it gets too hot, another about 2 watts resistor will be in series with it. It will take a bit longer to discharge this, but the heat output will be half, so they will dissipate less power and heat up less. Let's test with one and hope that it works like this. If not, we will add a second one. Okay, this was getting at about 50 degrees and presumably still going higher if I would have left it after a minute or something like that. Maybe even less than a minute, so I decided to stop it, and I'm trying to use a 480 kilo ohms that was actually in charge of bleeding down this Philips about 22 more times more powerful than this one from a TV, so I think it should handle this, but it will take longer to discharge it. We'll see how long. In theory, somewhere around 10 seconds, but this will also start discharging, so it should take way less than 10 seconds. I will check with the multimeter how long it takes and how hot this gets, again with the PicTech. So be back in a second. Okay, still zero flickering. Let's see some temperatures in here. So 28.5 degrees on the resistor itself, and also the capacitor has, what does it have, 24 point, almost 25 degrees the capacitor, and about almost 30 the resistor, and it's been running for more than a minute, and I will still let it run. It's been running for 30 seconds when I started filming this part of the video. I will let it run for a while, but this is 10 degrees over ambient temperature in this room. So yeah, I will also do a bleed test and see how quickly it gets rid of the voltage, because that's our main concern in here. But no, this one is not cooking itself at all, so that's good. That's really good. Oh, seems even a bit lower now. Presumably depends on how the air moves over it. Let me do a quick test, but I cannot do that on video. I don't have a tripod with me. You will just need to believe me, because I switch it off and measure as quickly as I can the voltage. So these are the values: capacitor, input voltage, and up to 25 volts, because from there on it's not dangerous, or at least not that dangerous for humans. This is 480 kilo ohms, so it takes 10 seconds to discharge it, and we are dissipating 0.11 watts on the resistor when running it normally at this voltage. But the LEDs will consume down to 80 volts, so basically we are just discharging from 80 volts. So that means, as you can see here, about 5.5 seconds. So, yep, this is working as intended. Yeah, it takes a few seconds for this to discharge the capacitor, about 5, 6, to discharge it basically from 80, where that thing cuts off. This starts working, and 5, 6 seconds and it's almost nothing. So that's perfect. But then I decided, hey, let me test what I get there when I unplug it directly, instantly. I get 0 from the start. So this might have been a non-issue, because I'm not going to put my fingers in here. This is on the wall. I cannot touch this capacitor. So I think the bridge, the diode bridge, is actually preventing the flow from this backwards, which if you think about it, kind of makes sense. So presumably somebody that knows electronics way more, or even a tiny bit more than me, knew this all along and was shouting that what I'm doing here is kind of unnecessary. But then again, I managed to discharge this little guy in 6-7 seconds, whatever, and the resistor is barely 10 degrees above the temperature of the room. So yep, I'm keeping this, making sure everything fits in here without a chance of contacting that, because that would suck, and testing tomorrow for a few hours in here with a cover on to make sure nothing overheats. If everything is good, it's on the wall, and the diode bridge doesn't even care that it's working, it doesn't heat up at all. So yeah, anyway, live and learn, work and learn, I guess. And we are ready to put this on the wall. I'm not using this hot glue as an insulator, I'm just using it as glue to keep everything tucked in there. Put some thermal shrink tubing on the capacitor. The resistor is deep down there, covered with this tubing, and the wires are behind, tucked next to the capacitor behind the tubing, so they will not break in the resistor area, nothing is moving in there. Then they come here in the bridge area, and they are not touching the hot glue. The hot glue is an insulator, but I'm not trusting it, so high voltage isn't touching the hot glue anywhere. Hot glue just holding the wires in place. Checked the ground between this and the ground pad in here. It's a perfect ground, so I have ground, and that's about it. Tomorrow I will leave this to run for a few hours like this on the bench. If it's not heating up, it's going on the wall finally. And if you're curious about the shape of the LEDs, here they are, just in the middle. But obviously they don't show up like that when you are far away, just when the camera is compensating. Decided to put some insulation tape in here just for good measure, although it was not needed, but can't do any harm. Checked it, nothing is overheating apart from this, which gets to 65, almost close to 70 at moments degrees Celsius. So the LEDs will cook themselves. I'm kind of annoyed that I forgot to measure this before doing the modification, but probably it was about the same, maybe a bit less, because the LEDs had that down time between the voltage spikes, which now is flattened a bit more by the capacitor, so the LEDs are a bit more time on, I think, probably. Anyway, so this will be going on it. I wanted to put a bigger one, but this cannot hold it. But this one from an Intel CPU, it can hold, but clearly, as you can see, a good contact I will have only in the middle. The rest of it will be touch and go. So anyway, I am putting it in here with some glue in the four edges, and obviously lots of thermal compound on the plastic under this, and hope that it helps cooling. The surface area will be much bigger and much better at transferring heat than this is, obviously. But who knows, maybe it will do absolutely nothing. Then I will just use it, and when it blows itself, I will put another light in here and only keep the rest. So basically nothing will remain from this whole bed design. I present you the Franken lamp. So this one, with a lot of thermal compound, as you can see all around, managed to get the temperature down by about 20 degrees. So it was on the back of this 70 degrees after, I don't know, 15 minutes or something like that. With this thing at about 15 minutes mark, it was about 50 degrees, so 20 degrees lower. If I let it more, it saturates and goes to about 55 degrees max. So that's okay for the LEDs. They are not cooking anymore, but it was the hottest right there in the middle where it's just a lump of aluminum. So I decided to also put some compound right there, put another tiny heatsink and just a tiny bit of glue on the corners. So we are cooling it even more. And yes, this can hold the edit weight. I checked, that's why I didn't put something bigger, because this wouldn't hold it anymore. But how it is now, it holds it, and this will not fry itself. But it's not looking anywhere near as it looked when I bought it. And obviously all of this, I had them, but if you would need to buy them, they cost money. Finally, it's on the wall, but it looks nothing like it used to at the beginning. But hey, if I need a bit more light when filming something or working on something, I push a button and voila, more light. Yes, the overheating could be due to the fact that the LEDs are now always on, and before they had a moment when they were off. But yeah, I can't deal with flickering, so bad design from the start. And yep, this thingy, let me show you, it will start to heat up, but nowhere near as fast as it used to without this huge aluminum heatsink on it, which is still light enough to not be a problem for the arm. Yeah, we are way low at the moment. It will rise slowly, but not to extremely dangerous levels anymore with this. So yeah, that's about it for this video. Hope it helps you. Depending on what you need to do with this thing, it's either a really bad buy or not too good one, or maybe you like it. You saw everything here, from good to bad, from nice to ugly. That's about it. Let me continue working on this space. See you in the next video. Bye. And this is a reading with it installed in here. We are not even going to 50 degrees because it's a bit colder in here. So yeah, we made it work somehow.